All right, so we're going to continue with transformations of functions. Previously, we had just been identifying functions, and we were specifically looking at translations. So we would look at something like this. We would look at f of x minus 3, and then let's say plus 5. And we looked at both of these numbers, the minus 3 and the plus 5. And we looked to determine what that did to our function here. So if I'm looking at this minus 3, does anybody remember what would this minus 3 do to our function? Where would that move our function? If it's inside the parentheses, it's either going to move us left or right. And if it's minus, which direction is that going to be? It's going to move us right, correct? So we would say the function moves right 3 spaces. And what about the plus 5 that's outside the parentheses? What would that do to our function? It would go up 5 spaces, correct? Thank you. And so that was all we were really doing when we worked with this previously. Today, though, we're going to see something similar. We're still going to have this f of x. We're still going to have numbers inside the parentheses, outside the parentheses. But we are going to be modifying a function. We are going to be changing a function, which means we're going to be changing an equation. So we will use the given transformations to change our equation in some way. So we will be doing a little bit of calculating. We're not going to be solving for x. We're not going to get x equals as an answer. We're not going to get a single number as an answer. The answer that we are going to end up with is a function. So we will start with a function as what we're given, and we will still end with a different function as our final answer. All right, so let's take a look at a few examples here. We're going to start with a function, like I said. So let's have f of x equals 2x plus 1. Nice and simple, nothing fancy there. We just have 2x plus 1. What we are asked to do is we are asked to find some kind of modified version or transformed version of our original function. So you might be asked to find f of x plus 3. So notice, we're asked to find something that has essentially 2 parts. The f of x is one part, and the plus 3 is a separate part. Now, this may seem like a bit of an existential question, or may seem like a little bit of an obvious question, but what does f of x equal? What did we just say that f of x was equal to? Two x plus 1. Because this f of x right here is the same as this f of x right here. Those are the same thing. So I can take this f of x and replace it essentially with 2x plus 1. I can substitute that in. Now, have I messed with this 3 at all? Have I done anything with that 3 yet? No, I haven't. So that's going to stay the same. So let me change my color. So I'm color coordinating. So that plus 3 is going to stay here on the end. So I took f of x, because we have f of x plus 3, and I took f of x and I substituted in what I know f of x is equal to. We know that f of x is equal to 2x plus 1. So I replaced this f of x with 2x plus 1, and I kept that plus 3 the same here. Now, I just need to simplify. What are my like terms here that I can combine? One and 3. So the only other thing that I need to do here is I need to do 1 plus 3. And so that's going to give me 4. And then the 2x is going to stay the same. We didn't change the 2x at this stage. So now I have 2x plus 4. So I can say f of x plus 3 is equal to 2x plus 4. There's nothing else I can do to simplify. So this right here is my answer. Questions on that example? I want to show you another example here in just a minute. But for the moment, that's really all we need to do there. If we see f of x, we can replace f of x with the f of x that we already have. So this time around, let's find f of x minus 9. So just like before, I'm going to use the same f of x. I'm going to use this same f of x that I had here. So this f of x is the same as this f of x right here, which means I can replace this f of x with 2x plus 1, just like we did in the last problem. Just like in the last problem, I also did not change this number that was subtracted on the outside. This minus 9 is going to stay exactly the same. That was a little bit wonky here. So that minus 9 stays exactly the same on the end. All I did was replace the f of x with 2x plus 1. I substituted in the function that I already knew. Now, once again, I need to simplify. I see that 1 and 9 are like terms, so I can do 1 minus 9 in order to get negative 8. but that 2x is going to stay the same for right now. So now I have 2x minus 8. So I can say that f of x minus 9 is equal to 2x minus 8. What questions do you have? What is confusing? What's not making sense? Now, one thing to note, because this is a little bit different than we've seen before. Notice how I left this +3 on the left side. Notice how I left this minus 9 on the left side. We are not changing the left side at all. The left side of our function is given to us. The left side of the function is not going to change. We are only modifying the right side of our function here. Let's actually add that into our notes. So we are not changing anything about the left side of the function because we are told what that should be. That's what is shown to us in the problem. We are only going to be modifying the right side of our function here. All right, so I've got a problem for you all to work out. Hopefully these are making sense and hopefully this isn't too difficult, but I want you all to try this one out here. I want you to find f of x plus 12. All right, so just like the other ones, we're gonna, oops, that's not what I want. We're gonna replace f of x with 2x plus 1. The plus 12 is going to stay the same. And we have f of x plus 12 on the left side because this part right here should always match the left side of our function here. That f of x plus 12 that we're told to find, that is basically telling us what the left side of our function should look like. So now we know that the 2x is going to stay the same here, but 1 plus 12 is going to give us 13. And so that gives us our final answer. All right, questions on this example here. As I was walking around, it looked like most people were doing good with this. All right, let's look at one more example together before we change too much here. This time, let's have a different function. Let's have g of x equal, oh, I'm gonna need to write this out by hand. Let's have, oh, come on, mouse. G of x equals x squared is going on with this mouse? X squared plus 7x minus 5. So we've got a more complex function here, but it doesn't necessarily make our problem more difficult. We're asked to find g of x plus 15. So we have a bigger function. We have more things going on in the function, but it doesn't actually change too much about what we're doing. But we're going to be using a different function this time rather than the other time. Similar to what we saw before, we need to substitute in for our g of x right here. Well, in this case, g of x here is the same as the g of x that I just gave you, which is the same thing as x squared plus 7x minus 5. So I'm going to substitute that whole thing here in for this g of x. Got x squared plus 7x, minus 5, plus 5, minus 5 right there. And similar to the other problems, I see that I've got this plus 15 on the end here, which is a vertical translation. It would move our graph up 15 spaces. But that is also going to go on the end right here, because that part, that plus 15, did not change. All we're doing is substituting in what we know g of x to be equal to. So in this case, what are my like terms? What are the two numbers that I can actually combine here? I thought I heard it, but a little louder, because I couldn't hear you with the mask. The -5 and the 15 is hopefully what you said. So these two right here, those are going to get combined. -5 plus 15 will give us positive 10. But then everything else stays the same. There's nothing else that we need to combine here. That looks like a 40, not a plus 10. There we go. That's better. So the 7x stays the same. The x squared stays the same. And we still have g of x plus 15 on the left side. So even with a bigger function, even with a bigger problem, this is still relatively simple. Questions on this example here? We've seen some problems where we're adding or subtracting outside of our parentheses. We're performing a vertical translation. We're moving our graph up or down when we add or subtract outside the parentheses. But the next thing we want to look at is we want to look at what happens when we add or subtract things inside the parentheses, because that process is a little bit different here. All right, everybody got this? All right, so this time, let's have f of x equals 5x minus 4. And we are going to find f of x plus 1 with that plus 1 inside the parentheses here. So this is a little bit different because we have that plus 1 inside the parentheses rather than outside the parentheses. Now, side note. If I want to find f of 3, just a regular 3, like we did on the last test or like we did last week, what do I need to do in order to find f of 3? What would I do with the number 3 here? We would plug it in for x. So if I have something inside the parentheses that's different than x, I need to plug that something in for the x in my function. Anytime that the thing inside of parentheses, whether that is a number or a variable or a combination of number and variables, anytime that that is different than x, we need to replace all of the x's in our function with whatever we have inside. So in this problem, notice I have replaced the x inside parentheses. Oops. Oh well. I have replaced the x inside the parentheses, not with a single number, but with a phrase or an expression, x plus 1. And so what we're going to do is we are going to take this x plus 1 and we are going to replace this x with this whole expression. We're going to replace the single x here with this whole expression inside parentheses. So our left side is going to be just like before. It's going to be what we're told to find. So f of x plus 1 will be the left side of our function. The right-hand side of our function is going to be very, very similar to what we started with. We're still going to have the 5 here. We're still going to have the plus 4 on the end. But rather than having just x right here, I'm going to replace this x with what I have in parentheses here. Specifically, I'm going to replace it with parentheses x plus 1. So this x plus 1 replaces the single x that I started with right there. Is that making sense how I did that? Rather than substituting in a single number like we were seeing last week, we're substituting in an expression. We're substituting in x plus 1. Excellent, excellent observation here. This should still be a -4. I made a mistake. That should absolutely still be a -4. If you ever think that I have randomly changed something, please let me know, because there's a decent chance that I did. Just tells you that it's okay to make mistakes. We just got to fix them. So everything should still be the same as our original function, other than we have replaced the x with the x plus 1 in parentheses here. Now, just like our description over here, we need to simplify. What would I do first if I wanted to simplify this? If we have a number in front of parentheses, what do we do to simplify that? We can use the distributive property. We're going to take this 5 and we're going to multiply it times by everything that's inside the parentheses, 5 times by x, but also 5 times by 1. So 5 times by x will give us 5x. 5 times by 1 will also be 5. But we still have this minus 4 on the end here. So then we need to simplify by combining our like terms here. We've got plus 5 and minus 4. And so when we subtract those, we should get a 1. But the 5x out front will stay the same. Questions, concerns, comments? Some of you may be looking at this and saying, oh, there's a plus 1 right here in the parentheses, and there's a plus 1 here for a final answer. That is just a coincidence. It's just the way the problem happened to work out. We do have to actually calculate everything. Let's go through another example together so we see that it doesn't always work out that way. So this time, I'm going to erase this over here. This time, we're going to find f of x minus 3. Very, very similar process that we're working through. Mathematically, not doing anything other than adding, subtracting, multiplying, and, well, no dividing on this problem. But we are going to substitute x minus 3 into our function here. So this x minus 3 right here, that is going to replace the x that we saw in our original function over here. So the left-hand side is going to stay. Left-hand side is going to be what we were asked to find. So f of x minus 3 is my left side. I know my 5 is going to stay the same. Minus 4 will also stay the same. But now instead of just an x after the 5, I'm going to have parentheses x minus 3. Because that gets substituted in. Now, just like before, I need to simplify. So I'm going to take this 5 and I'm going to distribute. I'm going to multiply times by everything inside the parentheses. So that's 5 times by x, but also 5 times by negative 3. So this will give me 5x minus 15. We still have the -4 on the end here. And now we want to combine like terms. So this -15 and -4 is going to give us -19, because if you borrow $15 and you borrow $4 more, you now owe somebody $19. But the 5x is going to stay the same. And that's it. That's our solution right there. How you feeling about this? All right, all right. Let's have a problem for you all to try out, okay? Similar to the last two. So I want you to find f of x plus 6 here. Sort of running out of space here. All right, so just like before, I plugged in this x plus 6 in for the x that was originally in my function. The 5 stayed the same, the -4 stayed the same. We're going to distribute. And so this will give us 5x plus 30. We still have the -4. And so then we combine our like terms. 30 minus 4 is going to give us 26, and the 5x will stay the same out front. And so that should be our solution here. As I was walking around, it looked like most people were doing a good job with this. Questions, concerns? All right, so the last thing we want to look at is we want to combine the two things we've seen together. So let's look at a function. Let's use f of x equals 3x minus 7. And then we're going to be asked to find f of x plus 2 plus 5. So notice I have a number inside the parentheses that's being added. I also have a number outside the parentheses that's being added. So I have two different numbers that are modifying this function. So we're going to have to be extra careful when we set this problem up. So I'm going to color coordinate in more than one way. So similarly to the last examples, I need to replace the x that's in my function with the expression x plus 2 that I have inside my parentheses here. I also need to make sure that I have this plus 5 on the end of my function right here. So let's start by substituting in the x+ 2. Let's start with that and we'll work from there. So I know first off that my left-hand side should be the same as whatever I have right here. So I'm just going to write that down. So fx plus 2 and then plus 5. I also know that the 3 and the minus 7 are not going to change. Those are going to be the same because those are part of the original function. So I'm going to have 3 out front. I'm going to leave space for my parentheses, and I'm going to have minus 7. And what should go inside my parentheses here if I treat this the same as the last few problems we just went through? It should be x plus 2, right? So inside this parentheses, I've got x plus 2. So inside this parentheses here, I need x plus 2 right here. That's going to go right here. I'm going to make that 7 look a little better. 7's looking a little funky. There we go. But now I also need to take this plus 5, and I need to take this plus 5 and put it on the very end right here. So we need to make sure that we have both of these numbers incorporated into our modified function, our transformed function down here. Now we need to simplify. And there's a few different steps that we could do first. I'm going to choose to distribute first, but you could actually start by combining the negative 7 and the plus 5 right here. I'm going to choose to distribute first. So 3 times by x and also 3 times by 2. So 3 times by x will give me 3x. 3 times by 2 will give me plus 6. Have I done anything with the 7? Have I done anything with the 5? So I'm just going to bring those down. Minus 7 plus 5. Haven't done anything with them. They just came straight down. Now, what like terms do I have to combine? What numbers can I combine together? Negative 7 and 5, but also 6. So all 3 of these numbers here are regular numbers. They don't have any x's, so I can combine them together. And the important thing is that we're combining left to right. So 6 minus 7 is going to give me negative 1. And negative 1 plus 5 will give me positive 4. The 3x, once again, did not change. So that's just going to come down. And so I have 3x plus 4 right here. Questions on that example? All right, let's go through one more example together. And then I think we should call that good. Let's do f(x) minus, I just did 6, f of x minus 7 plus 1. If you feel like you know what you're doing, feel free to try this one out on your own, but I'm going to work through this here. Oh, I should actually add the directions in. So as always, this part is going to give us the left side. So f of x minus 7 plus 1 will be the left side of our function. I know that my 3 and my minus 7 are going to stay the same from the original function. So this 3 that's going to be out front is going to stay the same. I'm going to leave some space for my parentheses, and I'm going to have minus 7. Now, what should go in my parentheses here for this problem? What do I have in the parentheses in what I'm asked to find? X minus 7, not just the negative 7, but the x minus 7 here. So the whole thing is going to go in parentheses down here. X minus 7. I also have this plus 1 outside of the parentheses. And so I need to make sure that I have a plus 1 outside of the parentheses over here. Just like before, I want to distribute. I want to take this 3 that's in front of the parentheses and multiply it times by everything on the inside. So 3 times by x, but also 3 times by negative 7. So that gives us 3x minus 21. And then we're going to have minus 7 staying the same, plus 1 staying the same for the moment. And then we're ready to combine our like terms. So we know that this 3x is going to stay the same right here because there's no other x terms to combine with. But now we have negative 21 minus 7, which will give us negative 28. And then negative 28 plus 1 will become negative 27. And so 3x minus 27 will be our final answer here. X, plus 1. And so 3x minus 27 is our final answer there.